Hello everybody and welcome back. Today I want to do a quick video tutorial on what it would look like to create a very simple SQL database. This is going to be using PostgreSQL, which is one of several flavors of SQL, or the structured query language. And this is going to be using pgAdmin 4 as our tool to essentially communicate with this database. Again, this is one of many ways, and this is a very diluted example just to give you a simple example of what exactly a database is, what it looks like, and kind of the purpose that it serves. Before we get started, as always, please feel free to like and subscribe just because I post content pretty regularly and would love to know your thoughts and have you continue to check back in. Also, don't forget to comment below not only on your thoughts of this video, but just to kind of tell me what it is that you liked and want to learn more about. Now, going ahead and jumping into the video, I have a couple links in the description, one of which is to another video I have just kind of giving you a rundown of what SQL is and what a database is. And then there is actually a separate video to a class. It's not a class that I myself created, but it's where I learned all of this information, and I think it is a great stepping stone for anyone interested in learning about databases, whether it be something that you do as a hobby or for a career. So let's go ahead and jump in. First, I just want to show you that course. It is going to be on Udemy. The third link in my description is just kind of a run through of what Udemy is, and as a kind of like a unique platform to learn about various tips, tricks, tools, things in IT, and a variety of other industries. So if you were to go to Udemy's homepage, we'll end up at this page shortly. But going to udemy.com, at the search bar, we would type in SQL, as that's what we're interested in learning about. And then we would have this, the complete SQL Bootcamp 2020, go from 0 to hero. I do want to let you know that I am not being paid or endorsed in any way by Udemy or the instructor of this course. It's just, I think, a great course and platform to learn. You'll notice it says it's $129. You can often find coupons and discounts to bring this down closer to 10 or 15. I know that may seem like quite a drastic cut, but it's a unique pricing strategy on their end. You're looking at about 7.5 to 9 hours of content, which overall I think is more than worth it. You can scroll through this page to learn about the requirements, descriptions, see reviews, related courses, etc. But don't want to spend too much time on this, just kind of wanted to give you a quick rundown. Now, getting started with our database. We're going to be running into a program called pgAdmin 4, again, to kind of help us interface with this database. We'll kind of call this the Excel for this example. Now, in Excel, I do have a sample database, or sample file, I should say. It's named Book 1. We will go ahead and rename this mentally to YouTube_example, just like we have named this first workbook here. Now in SQL, the file is going to be the database. So book 1 would actually be our database, and then this workbook would be our table. You can create a final table, sheet 3, sheet 4, just like you can create multiple tables in SQL. The advantage is, just like you can use VBA in Excel, in SQL you can essentially use this structured query language to pull smaller pieces of information and refine larger data sets. So you can have a table with hundreds, thousands, millions of entries, but you may want essentially 1 to 2 of them. For example, if we were pulling a database and we were working for a company like Netflix, you may want to know all of the customers that have an unpaid bill, or for any other random company. Maybe you want to reward customers who have been with the company longer. You'd look through the database, but if you have millions or more entries, you can't just scroll through like you could with Excel and pick out every one. Or at least you could, but it would take a very long time. So this is a more efficient way to pull that information. So here's a quick sample of what we're going to create, and then it'll develop over the course of the video. Now, in PostgreSQL, we are going to go to the databases section, and this is pretty much what the page would look like as soon as we log in. So we are just going to go to databases. Right-click, click Create Database, and then here we're going to type in the name, which is going to be YouTube_example. And then we will go ahead and click Save. You'll see the number next to databases will change over to 6. Often when we make a change, we will just refresh. And then when you expand on databases, you'll see several. Some of these were from the course I was taking. Some of them were just practice courses themselves. When we click on YouTube example, we will connect. And we will right-click click it, and we will scroll down to Query Tool and click. And then here we have kind of like our base platform. Here is our query editor where we will type our commands. And over here is a scratch pad. Things you type in over here, they really don't serve a purpose. They are just kind of like your general notes as you're getting into more complicated commands. It does not affect what you're doing over here. Now, to go ahead and get started, I have a couple commands that I have pre-typed just to save us a little bit of time. So we're going to go ahead and get started by creating a table. So I'm going to copy this command that I typed up earlier, and then I'm going to paste it into PostgreSQL so that we can see how it color codes it and break it down further. Now we have a command that is going to be creating a table. It is going to be YouTube example, and it's going to have 4 columns, just like we have here in Excel. And we're going to have number, which is the first column, letter, random, and created. Now with SQL, you'll notice that the number is purple because it is a command, but SQL is an intuitive language, so it knows that this is a column name based on the syntax. So we're creating a table with the name YouTube example, and it's going to have the columns in parentheses. So we have number, which we're going to list as a serial, type, a primary key. You typically have a primary key in tables in SQL. You can learn more information if you're interested. Again, leave comments below. I don't want to create a very, very long video because breaking all of this down would take much longer. But you can learn more about this. But just to keep it simple, this is going to create a number column where it's going to be unique numbers, and this is the primary key for the table. And it is going to create a letter column with a variable character, or varchar, which is limited to 10 characters, which is going to be unique, and it can't be null, which means it can't be left blank. So we're essentially creating rules for this table or for this database. Then we are creating a random column, which is a variable character, again with a length or a max of 10 characters, not null, meaning it doesn't have to be unique. So this could be random column, each entry could be 1, as opposed to this column, which would be 1, the next one would have to be 2. The difference with serial is automatically going to essentially input that information. So let's just say we created this database, and it looks like this table here. We know that the letter column is a variable character, and then the random column is not unique. So this could literally be 11111. The letter column would have to be, let's just say A, even though we haven't set parameters to force it to be a letter. We can't make this next entry A. It would give us an error. So it's going to be B, and then we'll just say C, D, E. And that's essentially what these relationships are. And then the number, if we didn't enter anything, is automatically going to fill with 1, because it is going to create the sequence. The next one would auto-create by the database as 2, 3, 4, etc. So just to give you a little bit of background, again, it may not make as much sense. You would need to have a little more of an understanding, but for time's sake. We are then going to have a column which is created. And this is going to be a timestamp, meaning it is going to be what would look like in Excel as kind of like a time format. So best way to explain it is in this table, for example, created column is a timestamp, which in Excel is the function, and it can't be left blank. So an example in Excel is we go to the created column, we right click and we click Format Cells, and we'll go down to Date, and let's just select the first one and click OK. Now in Excel, we'll treat this like as if it were SQL, and let's just say we wanted to enter in 4 and hit Enter. It's automatically going to create a date based on certain criteria. So it's not going to allow you to enter the character as if it was a general character. It's the same thing in SQL as it's creating a specific format for it or relationship. Now we will go ahead and delete all of this. So we'll go ahead and get started creating this table. We're going to hit this, which is going to be your execute, refresh. I just call it the play button because to me that's what it looks like. So we will go ahead and run this, and you'll see the query was returned successfully. Now we want to see all of the data because right now we just see a message that says we did it, but we don't know what exactly we've done. So we're going to hit Control A and delete, or just delete all the information. And we're going to select an asterisk, which is everything. from, and then we're going to type out our table name, which is YouTube underscore example. And this is how you would pull all the information. And then you'll see that we get a number column, which is an integer, a letter, which is a character verifying, or varchar, or varchar, or variable character. Random column, which is the same, and you'll notice the 10 in parentheses, which is the max character amount, and then the created. So with each column beneath, it will essentially specify that format that was listed, or the type or relationship. And now we are looking a lot more like this table that we have here. Now, what we're going to do next is we are actually going to do the same exact thing, but we are going to list this table, or call this table final. We ran this query successfully, so we're going to delete all of this. We don't need to return everything. We know that the table was created in the background. Visual representation over here, YouTube example, you go to schemas and you expand. We don't need to worry about all of this content. It can be a little overwhelming, but we'll just click on tables and you'll see we have final and YouTube example. So what we're going to do now is, let's just say we want to insert some values. So we will go ahead and copy this pre-typed query and we will paste it in. Here we are going to be inserting into the YouTube example table, and we're going to be inserting into the column number, letter, random column, and created, which is, if you remember, the 4 columns that we originally created. And we're going to be inserting the following values. Now you'll notice that these are in quotes, but current timestamp is not. And that's based on essentially the type of information that's being input now, or put into this table. You'll learn as you go along and you're typing in different queries that you're going to get error messages down here. And honestly, there is a very, very large community for SQL developers. So any issue you've run into, someone else has probably figured out an answer to. So you can typically either paste the query you have online somewhere, or Google the error codes you're getting and probably find a good, essentially, breakdown of what that error code means. But for this, we're just going to go ahead and click Run. We'll see query returned successfully, and down here you'll see return successfully in, I think, 98 milliseconds. That number will change based on the size of the query, size of the database, and a couple of various factors. But what we want to do now is we want to see, okay, we returned 1A, QWERTY, and timestamp. So what we just did was we put 1A, QWERTY, and then whatever the current timestamp is. And to be honest, I don't want to type that out because it in SQL will default to the millisecond if I'm not mistaken. So we'll just put 8-15-2020. Now this is what essentially our output is going to look like. So we are going to go here, delete everything, and we are going to select everything from YouTube underscore example and return. And you'll notice we have 1A, QWERTY, and then the timestamp in the default format, which can be changed. So we have actually returned our first query. So we have actually, as of now, although it may be a very simple example, created a database named YouTube example with 2 tables within that database named YouTube example and final. Although there's not much information, you'll understand that if we were to extrapolate this example, and let's just say this number column is an employee number, and we're a large retailer, Walmart, Target, something along those lines, this could be millions or more of employees. And then the letter, let's just say that's the employee's first name. And then the random column could actually be facts about the employee, or really just any kind of random information. And created could be the date that they started employment. And then there could be many, many, many more columns. And then obviously millions of entries. Well, what if you wanted to reward all employees who have been with the company for 10 years? In Excel, if there were millions of entries, you'd have to scroll through and read every single date, and you run the risk of an employee potentially skipping over employees or any number of things. So you could return a SQL command to pull this information, which we'll go into detail later, but as we're not creating a database of that size, it's better to kind of think on that scale, or kind of better understand it, again, with that visual representation. Now, quick example is we've already inserted those values, but what if we wanted to update them? We will use the next command, which is going to be update YouTube example, the table, and we're going to be setting number equal to 2. When we click run, you'll see returned successfully. So what we're going to do is the same, select everything from YouTube underscore example. And then when we return it, you'll see the number has changed to 2. What we basically just did was clicked on this cell, typed 2, and hit enter. That's your visual representation. But again, larger scale. It would not be as simple as just clicking on 2. Let's just say you had an employee who changed their name due to getting married. Then you would have to update their information in a database. That gives you a quick way of looking through if this table, let's just say, had millions of entries and employee XYZ is all the way down here in cell 104 or cell 1,020. You don't want to have to go digging through, so you'll type that in. Now, what if we decide, you know what, we need to go ahead and just delete all this information altogether, or specific information? We can go to our fourth command, and we're going to be deleting from YouTube example. I'm not going to specify because here we just want to delete everything and there's really only one column, but we'll go ahead and run this command, and then we will run the same, select everything from YouTube underscore example, and run, and you'll see this is empty, which was the equivalent of highlighting this column or this row and deleting. We are now back to square one, essentially. Now, what if we wanted to put in more information? We will go ahead and highlight our last command and kind of break it down a little bit further. Now, what we want to do is we want to insert all of this instead of into YouTube example, or in this example, random. We are going to insert it into a different table. But I want to run this so you can see what an error message would look like. So we'll click run, and you'll see insert into random. You'll see a SQL state and character. It essentially tells you that relation random does not exist and gives you an error message. This is because we never created a table named random. So what we're going to do is insert into table final. You'll notice this turns purple because that's actually a command in SQL, but we're creating it as a table name here, or using it as a table name. So when we click run, you'll see query returned successfully. So we are going to now just want to see what exactly this returned. So we are going to select everything from final. And then typically you're going to throw your semicolon at the end just to denote that you're done with the command. We've been kind of skipping out on this, but just to kind of make the syntax look a little bit more legible. And we will run execute / refresh. And you'll notice we have essentially created what would look a little bit more like a database. Now, we have an example of what this looks like here. If you were to go over to from YouTube example, which is live, essentially what we've created so far, but you have this final workbook. You'll see that we have number 1 through 12, letters A through L, and then our secret hidden message. Please remember to like and subscribe to my channel for more content, excluding the one misspelling. And then created, I was lazy and did not want to type in the timestamp, but essentially that would be the timestamp that was created here, which was just, as you noticed, current timestamp. Basically just the moment we ran the query, that timestamp was added into this column. So we've selected everything from the table to view this, but it could be any number of things. For example, one way to pull this information from this database to give you more of a realistic understanding of why create this database. Let's just say that there are millions of entries, and we really need to, for example, say employee 4 has information on their system that we need to pull up. Letter D, let's just say that's their first name. So we need to select everything from final where number equals 4. This is going to pull up employee 4, and it's pulling up everything. Again, this asterisk, that means that we're pulling everything, but where is specifying the column where the number is 4. What we just did was we essentially highlighted this column. If there were millions of entries, it makes it so much easier to pull this single employee. So if we wanted to know, we want to celebrate all of the employees' birthdays, then you could select all of the birth date column if that was created, and then determine all of the employees and pull the columns where all of the employees' birth dates were equal to today, which is what would go here. But there's so many different practical uses. So this is, again, a very, very diluted example, but it gives you an overview of the most simple way that a database would be created. There are multiple programs and multiple flavors of SQL, but it gives you kind of like a general understanding of why people are using databases and why they're so popular. And it's honestly something that you can learn pretty quickly on your own, depending on how much time you have and how much you want to learn. So if you have any questions, comments, concerns, feel free to throw them in the comment box below. Again, this was the quickest example. There's so much information to cover, as you can see, even on just this left-hand side. And as you can imagine, database developers, this is not the simplest version of what they're doing every day. This is, again, a very, very simple command that you could do, but what they're doing goes on a completely different level. So I would highly recommend, if you have questions, feel free to reach out in the comment box below. But I definitely recommend taking some classes online if this is something that you feel like learning more about. Feel free to, again, like and subscribe. Check into my channel for more content. I'll be posting regularly, and I look forward to seeing you in the next video.